Hello friends, I am Dr. Shivraj Narayan, working as Professor of Mechanical Engineering at VNR VJEC Hyderabad. Welcome back to the lecture series on engineering graphics. In this series, we are learning a software called as AutoCAD, which will be used for solving the problems of engineering graphics. In the previous session, we have learned some of the basic commands with reference to AutoCAD software and some of the draw commands. Today's session will be mainly focused on modify and dimension commands. So what you are going to learn from this session is that you will be able to create reference points using point command. Then you will be able to modify existing drawings using modify commands like move, copy, trim, mirror, and rotate. Also, you will be able to apply dimension commands such as linear, aligned, angular, and radius. And at the end, you will be able to prepare accurate and properly dimensioned drawings for engineering graphics problems. So let us move to the demonstration. So you need to open the AutoCAD software, and after opening, now what I'll be doing is I'll be reopening yesterday's or the previous session's file. So in the previous session, we have already created this layout of sheet. So you can open this file, go to File, Save As, and then change the file name to Engineering Graphics, that is EG Practice Sheet 2. So by doing this, our time will be saved in terms of creating the new layout of sheet. So the very first command that we are going to learn today is point command. So for that, you need to type point PO. And then either you can click anywhere on the screen, or you can define certain coordinates like 200, 200. Now what has happened is the point has been created, but we are not able to see it because of the size of the point. So in order to make the point visible, we need to make use of one more command that is called as ptype. So you can type ptype and press enter. Now you can see this point style dialog box appears. Through this point style dialog box, we can change the style of the point, the way the point appears. Its appearance or the shape can be changed, as well as its size can be changed. So what I'll do is I'll select this circle as the appearance of point, and the point size will retain it as 5, but the change that we'll do is set size in absolute units. So with reference to the absolute system, we would like to have this point size, and then click OK. So now here you can see the point has been created. Earlier, this point was not visible. So whenever you want point to be appearing on the screen, you need to always go to ptype command and change its style. Now why do we have to make use of this point command? We have topics such as projections of points. Similarly, we need to divide various elements, so wherein we should be able to see the points that are divided. So this command is really handy for it. Then the next command is arc. So either you can type A or you can type arc and then press enter. So what the software will ask you is the first point, second point, and third point of an arc. So you can just go on clicking, you'll be able to get the arc. So this is a random arc. But if you have specific values, then how are we going to draw the arc? So for drawing such arc, first I will make the ortho off. So ortho off can be made by pressing F8 function key, or you can as well click on this icon which is shown at the bottom. So I'm making the ortho off, and then again typing A for the arc command. Now you can see in the command prompt, it is asking specify start point of arc, or in square brackets it is center. So now we'll go with the center option. So we'll click on center. Then it is asking specify center point of arc. So either you can specify some value like 250, 250, press enter. And now what the software is asking you is either you can define the radius and the angle. You can see the preview. So at present the radius value box is active. So I'll type 50 in it and then press tab key. So when I press the tab key, so what happens is the value that has been typed gets locked. So that means the 50 mm radius value will not change now, and the cursor has now moved to the angular tab. So I will type angle as 45. So now what we are doing is we are drawing an arc with radius and angle value. So like this, you can create arcs randomly, that is dynamically. You can click anywhere on the AutoCAD screen and create an arc, or you can give precise values. So once again I'll demonstrate arc, then go to center option. Anywhere you define the center point, then type the radius as 50. Now click the starting point and then define the angle value, or you can click anywhere. So always the arcs are drawn in the anti-clockwise direction in AutoCAD. If you want to draw the arcs in the clockwise direction, while performing this operation of defining start point and end point, you need to press Ctrl key. So that also I'll demonstrate. So arc, center option. So now I'm defining the center point. I'll define the radius as 50. Now it is asking me to specify the start point. So somewhere I have clicked. So by default, it will always go in the anti-clockwise direction. That means the software will create the arc in the anti-clockwise direction. So if you want to draw it as clockwise, then press Ctrl key. You can see now the cursor or the arc is moving in the clockwise direction. So this is what is the arc command. So you can select all of the shapes, the objects that we have created, and after selection you can press delete key on the keyboard. So we also have a command called as erase command, which is from the modify group. So either you can type erase and delete it, or simply select the entities and then press delete key. Then the next we are moving to the modify group. Few of the modify commands we have seen yesterday. We have seen the offset command for creating the rows in the title block. So in order to perform modify commands, we need to create some shape. So what I'll do is I'll create a rectangle, a random rectangle. Now I want to modify this rectangle. Modify in the sense I want to change its position. I have drawn randomly somewhere, but this is not the desired position. So if I want to change the position of this rectangle, then I can make use of a command called as move. So you can type M and press enter. Type M and press enter, then the software will ask you to select the object. So select the rectangle, press enter. Next it is asking base point. So it is asking you a point using which or with reference to that point the movement should be done. So now I'll select this left side corner. Once you select it, the software asks you where you want to place it. That is the final destination point. So you just need to move the cursor and place it at the appropriate location. So this is how we can perform move command. Next, we have copy command. For example, our requirement is to have multiple copies of this rectangle. Then you can type CO. CO is the command for copy. And it works similar to move. So the moment you type CO and press enter, the software will ask you to select the object. So select the rectangle, press enter. Again it will ask you the base point, the reference with which the copies are to be made. So again I will select this left side corner point as the base point, and now wherever you want to place the multiple copies of this, you just need to go on clicking the destination point. So like this, we can make use of copy command. So I hope the move and copy commands are clear. they work almost on the similar functions. So move commands only displaces the original object, whereas the copy command gives us duplicate copies of the original object. The next command, and very frequently used command, is trim command. Now, what is the use of this trim command? If there are certain unwanted lines, unwanted entities, unwanted objects that we want to remove, maybe partially, then erase or delete is not the option. So for such partial elements to be removed, we have a command called as trim. And to activate that, we need to type tr. So type tr and press enter. So the trim command is activated. Now, whichever portion we don't want to have in our drawing, you just move the cursor over to that portion and click. So I just don't want this portion of rectangle which has pierced the original rectangle. So I'm moving the cursor over this portion and clicking on it. Similarly, I'm clicking on this vertical line. So you can see the two portions of the horizontal and vertical line of the copied rectangle which I don't want it to have been removed. So if you try to perform erase or delete, the entire rectangle will get removed. So whenever such is the requirement, we have to make use of trim command. Then there is another command called as extend. So I have drawn a random line over here, and I felt like this line should have been up to this rectangle. So whenever such is the requirement that you have drawn certain object, certain shape, and you feel like it should be up to some other portion or some other object, then we need to make use of a command called as extend. So for activating extend, you can type EX and press enter. And now move the cursor to the portion of the object which you want to extend. So I wanted to extend this line. So simply move the cursor on this line and you can see the software shows you the preview of extension. If you want it this way, you can directly click it. If you feel like it is not the correct direction and you want this line to be extended downwards, then just move the cursor towards the other end of this line and you can see it shows the preview in the other direction. So just move the cursor on one of the ends of the line and then click. So this is how the extend command works. So we have seen move, we have seen copy, we have seen trim, we have seen extend. The next modify command that we want to demonstrate is mirror command. So what if I want to create a replica of the objects that I have created? So what I'll do is I'll draw one reference line. I'll make the ortho on. So I've drawn a vertical line. This vertical line is the reference line. That means about this reference line, I want to create a mirror image of the objects that are already created. So I have created these three rectangles sort of shape and I want to have exactly a mirror image or a duplicate on the other side of it. So for that, I need to make use of mirror command, and for mirror you can type mi. So type mi, press enter. Then the software will ask you to select the object. So select all the objects that you want to mirror. So I wanted to mirror these three rectangles. Once the selection is done, press enter. Then the software will ask you to define the reference or the mirror line. So move the cursor to the end point of this line. This is the first point of mirror line. And then this is the second point of mirror line. The moment you define the second point of mirror line, you will be able to see a preview of the mirrored content. Now what the software is asking, do you want to erase the source objects? That means whatever is this source object, do you want to retain them or do you want to delete them? Do you want to erase them? So that is the option the software is giving. So by default, it is no, and we will keep it as no. So by pressing no, what happens is you will be able to get your original objects also as well as the mirrored object. If you press or click yes, then this original object will be removed. So this is how we can perform mirror command. Offset command we have already seen in the previous session. So offset command is mainly used for creating parallel lines or parallel entities, similarly concentric arc and concentric circles. Then the next command is rotate. So we want to rotate the object at certain angle. And in order to do that, we need to define a command called as rotate, and the shortcut is RO. So type RO and press enter. And then the software asks you to select the object. So select this rectangle. Once the selection is done, press enter. Then it is asking you the base point. So here also it needs a base point with which it will try to measure the angle. So I will define the left side corner point as the base point. I'll make the ortho off. And now you can define the angle. At what angle you want to rotate this rectangle. So I'll type the rotation angle as 45, press enter. So now you can see with reference to this base point, the rectangle has been rotated at an angle of 45 degrees. The angle measurement is also anti-clockwise in the AutoCAD software. So this is how we perform a rotate command. Then we'll move to the dimension commands. Now that we have created certain shapes, we also need to dimension them. So we have different types of dimension commands. If the entities, the objects that we have created are perfectly horizontal and vertical, that means they are linear, then we have a command called as dim linear. So as you can see here, in this rectangle, we have horizontal and vertical edges. So if you want to dimension these horizontal and vertical edges, the command is dim linear, and in AutoCAD you can simply type the shortcut as DLI. DLI, D is dimension and LI is linear. So DLI and press enter. Then the software will ask you to define the first point and the next point of the line for which we want to give the dimension. So select the first point and then the next point, and then the third point that we are defining is basically for placement of the dimension. So as you can see, initially we created this rectangle randomly without specifying any dimension values. So now you can see the value is 53.74. The horizontal line or edge has got a dimension of 53.74. Now I want to repeat the same command because I need to dimension the vertical edge. So for that purpose, what we'll do is we'll right click, and you can see the first option is repeat dim linear. So click on this. Now select the endpoints of the vertical line or edge. And the third click is for the placement of the dimension. Wherever you want, you can place it. So this is how we can dimension the horizontal and vertical edges. Now what if the line or edge is inclined, as in the case of this rectangle? So how do we give the dimensions of an inclined line? So whenever such inclined lines are present, we will not be able to dimension it using dim linear, but instead we will have to make use of another command called as dim aligned. Dim aligned. Dim aligned is the command for dimensioning inclined lines. So the shortcut for that command is DAL. D is dimension and AL is for aligned. So type DAL, press enter, and again the software will ask you the first endpoint and the next endpoint, and the third one is for the placement of dimension. So this is how we can dimension horizontal, vertical and inclined lines. Then the next dimension command is for angles. I want to show the angle. So the command is dim angular. Dim angular is the command for giving dimensions of angles. So you can type DAN. D is for dimension and AN is for angle. So type DAN, press enter. Now the software is asking you to select arc, line, circle, whatever you want to select. So I am selecting this line and this horizontal line. So as you can see here, it is showing the angle value as 45, and if you remember in the rotate command we have used this value. We have rotated the rectangle at an angle of 45 degrees. So the same value is being displayed over here. So this is how we can dimension angle values. Now what if I have a circle or an arc? Because for circle as well as arc, we need to define either the radius or a diameter of it. So for that we have a command called as dim radius or dim diameter. So first I'll create a circle, and for creating circle I'm typing C, press enter. Draw a circle now. So I have drawn it randomly. Somewhere I have defined the center point, and similarly radius also I have not specified, just I have clicked on screen. Now in order to dimension this circle, we need to type DRA. D is for dimension and RA is for radius. DRA. So by using this command, we will be able to show the radius of circle. So type DRA and press enter. Select the circle and then place the value. So here you can see the radius is 42.47 mm. What if you don't want to show radius but you want to show the diameter? So for that type dim diameter. So D, D, I. D is for dimension and DI is for diameter. So type DDI and press enter. Select the circle and then click for placement of this diameter. So diameter in AutoCAD is shown with this standard symbol of phi, whereas radius is with capital R. So this is how we can give dimensions in AutoCAD to arcs or circles, similarly horizontal vertical lines, inclined lines as well as the angles. So these are the mainly used dimension commands which are needed for us in solving the engineering graphics problems. Now apart from this, there are few more commands which we'll have to make use of. One command is divide command. We have drawn a line and that line needs to be divided into some number of parts. So I will first draw a line. I will make ortho on by either by pressing F8 or by clicking on this icon. Randomly I have drawn a line of certain length, and this line I want to divide it into some number of parts. So for doing that I have this command called as divide. So you can type div, press enter, then the software asks you to select the object. So select the line, enter the number of segments, how many parts you want to make. So for example, I want to divide this line into 8 equal parts, so I am typing 8. The moment you define the number, you are able to see the division points on this line. Now why these points are visible? Because we have already changed the point style and size using p-type command. If you don't change the point style and size, and if you are with the default option, then these division points will not be visible because those points will get overlapped with the line weight or the line width of this line. So this is one of the most widely used command for dividing, be it a line, be it a circle, and we'll be using it in many problems in engineering graphics. So for example, we want to divide the circle also into some number of parts. So again I'll type div, press enter, select this circle, then it is asking the number of parts, number of segments, so I'm typing 12, press enter. So you can see the circle has been divided into 12 parts. So important command. Similarly, in engineering graphics, we make use of different types of lines. So if you want to, like as you can see on the screen, all the lines are of same thickness and they are all solid continuous lines. But we know there are various types of lines, a dashed line, a center line, and so many. So if you want to have such lines, then which command has to be used? So a command called as L-type. The way we have defined p-type, which is for defining the style of a point, similarly we have a command called as L-type, which is used for defining the styles of lines. So type L-type and press enter. So this L-type or the line type manager dialog box appears on the screen, and you can see by default there are only 3 line types which are basically solid continuous: bilayer, biblock, and continuous. So where do I get those different line types now? So for that you need to click on this load button. So by clicking on the load button, you can see the library of different line types that are available in AutoCAD. So whichever are the lines that are needed for us in engineering graphics, that you can load now. So we'll make use of center 0.5x, click OK. Similarly, click on load, and you can go to dashed 0.5x, OK, and then close this line type manager dialog box by clicking OK. Now how do I get those line types? So for example, this line at present is a continuous line segment, and you want to show this as a center line type. So simply select the line, right click, go to properties. Select the line, right click, go to properties. You can see this properties dialog box. In this, you have got this line type as the third option, color, layer, and then line type. Click on this line type, and you can see whatever line types that we have just now loaded, they are also visible. If you don't do that, what will happen is it will only display the standard 3 default line types, which is by layer, by block, and continuous. So since we have added 2 more line types, it is showing that. So I'll select this center, and the moment you select center, you can see there is a change in the appearance of the line that we have drawn. Similarly, you can go back to this line type and select the dashed, and you can see it is changing to the dashed line type. So this is how you can change the line type. And at the end, like whatever shapes we have drawn, in engineering graphics, it is very important for those shapes to be drawn or shown correctly. You will be drawing many lines, many arcs, but you need to show what is the final answer. So plenty of construction lines will be there, but within those construction lines, you will also have your final answer. So which we call them as outlines. So those outlines we need to show as thick. Now how do we make these lines as thick? So for example, this rectangle is my final answer, and remaining all these things are construction lines. So in order to show this as my final answer and to make this as thick, what we will be doing is we will select this rectangle, right click, go to properties. So the same dialog box appears. Now here we have got a line weight option, color, layer, line type, then line type scale, then plot style, then line weight. So click on this line weight and just select 0.3 as the, or 0.3 or 0.35 as the line weight. Now you can see the difference. The line has got thicker as compared to the original one. So this is how you can show your final answer, final shape as thick using the line weight command. So now to conclude, I'll say today we have learnt about point command from the draw, then arc command, then we have seen many of the important modify commands like move, copy, trim, extend, rotate, divide, and then we have seen how to dimension the shapes or the objects that we have created. Now what I want you is to practice these commands and complete this practice task, wherein you will have to draw a square of side 25 mm, then draw a vertical line parallel to it at a distance of 15 mm, use the mirror command so as to obtain the replica of it, and then finally dimension it. So we'll meet in the next session, wherein we'll start about solving engineering curves problems. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.